that better?
There we go.
All right. Okay, we'll talk a little bit about actual pieces of radios. Back in the old days, of course, I guess it wasn't all that long ago. We had separate receivers and transmitters. Transceivers are sort of a modern invention where they package them both in the same unit. Particularly for the handhelds. I mean, we didn't have a handheld transceiver back 50 years ago. I don't think.
Yeah, it was one that was about this.
Did you have one, Byron?
Say that again?
Did you have one back 50 years ago?
No, I didn't get into this until 94, I believe it was.
Oh, wow, you're a newcomer.
Yeah, young pup.
So basically, transceiver is just a device that combines both the transmitter and receiver into a single package, and they share a common antenna and power supply or power source. There's also a transverter, which is a device that will convert usually a VHF UHF signal into an HF signal that you can use with an HF radio. In other words, you connect it to your HF radio, and it now will allow you to transmit and receive on the VHF UHF bands through that transverter. Kind of uses the input frequency on the HF as another IF signal.
Usually you don't see that anymore unless you're using a radio that's gonna do a microwave, really high frequency stuff. Because, you know, the inter-radios now will do 2 meters, 70 centimeters out of the box, but if you want to get up 1.3 gig, 2.
Yeah, mine, that's what, 23 centimeters,
Yeah,
1200,
23 centimeters,
which
33
mine
centimeters.
97 does those three.
Yeah,
But the T41 I'm building, there's an optional transverter board
yeah.
to do 2 meters.
I know my brother told me one time they did a little carpool convoy from Atlanta to here. And they went and got the little motion detectors at Home Depot, and they're using that for their transmitters from car to car.
Ah,
And they said the only problem is that you would hear the Doppler effect of traffic in the other lane.
okay. So what is a transceiver?
Alpha.
What device converts the RF input and output of a transceiver to another band? Okay, typically your handhelds are going to be 5 watts. Some of them they claim are 8 watts. I don't think I've seen any higher than that as far as a handheld. I think maybe part of the reason when you do the RF exposure calculation, you're going to get 10 watts and above, probably can't hold it that close without being in excess of the radiation level.
I think Baofeng sells a couple a little bit higher.
It's supposed to be 72.
Yeah, some of the
2 watt.
the one I have, which is a Baofeng clone that's supposedly fixed, claims 8 watts. I don't know what it really is.
There you go.
This one says 8 watts.
But like you said, you probably get 5 out of it,
Yeah.
the tops.
Depending on how good a match it is to the antenna,
Mm-hmm.
which is something they don't ever deal with on handy talkies and even mobile as SWR. And there's no guarantee that you got a good match to that antenna.
And if you fill your stock antenna after transmitting a while, it gets pretty warm.
Most mobile transceivers designed as a mobile are gonna run around 50 watts. And most base stations are typically 100 watts nowadays. There's a few exceptions. Some of the more high end, I think that $13,000 ICOM is 200 watts.
Yeah.
You can use a power amplifier called a linear to increase power all the way up to the legal limit. And it may have, and probably does have, a mode switch so that you can set it in the correct operating mode depending on what you're doing. And some of the newer ones, solid state, that's probably automatically programmed
Mhm.
between the radio and the power amplifier. But older ones, it was a switch and you had to set the mode.
What's the limit on the linears now?
1,500 watts.
1,500 watts.
Most of them are less. Normally you see 1,000 or 500 and a few 800. The Ameritron I have is 800. Which is half, it's only 3 dB down from legal limit. So
That's,
half an f-stop or S unit.
That's Bravo.
It's Bravo? Okay. What's the function of the single sideband CW FM switch on a VHF power amplifier?
Ain't no way. And I'm not my radio that can do that. Always my radio that can do that.
I give a,
Always buy a radio that can do that.
What can you eliminate?
I don't know.
Get rid of Delta.
Yeah.
I,
Get
I,
rid of-
I think my brain switched off a few minutes ago.
Okay.
Ooh.
Well, your power amplifier isn't going to have anything to do with received signal noise. So we know it's not Delta.
Yeah, okay.
It's not supposed to be changing frequencies for you.
Mhm.
So it's not Charlie.
Not Charlie.
So it's Alpha or Bravo. And I didn't even read Bravo.
Maybe you should have.
I should have.
I was thinking it was green.
Well,
It is.
Okay. You're
See, you don't always listen to
I
Byron.
know,
say
kept
don't-
reading it over and over.
Yeah.
I'm like, that's.
Yeah, it is Bravo. I just, once
it is Bravo. Yeah.
Right. You put the amplifier in the right mode. You don't change the mode of the signal.
Yeah,
I was doing
Yeah.
that. Like,
Every
you
question.
better read the question, every answer. I'm like, okay.
Right. And read the question twice.
Yeah.
And read every answer before you pick one.
Well, look at them when you're saying, that, not me.
I don't have to pass the exam.
Oh.
I've already done it.
True.
Besides, did you take my exam from hell?
No,
Oh, okay.
Nobody will do that. Bob.
Huh?
Nobody will do that.
Oh, yeah, but I had several extras take it and they didn't get them all.
I took one maybe a month ago. You had one out that I took.
Oh, this was back
Are
couple
we
months
supposed
ago.
to take your test from hell?
Yeah.
We are?
She said, we are.
Oh, yeah.
You will have the option.
Well, you don't have to, but
It's
it's a good way to see what you need to work on. And the odds of getting all of those questions is like nil. I picked the hardest ones.
Hmm.
So, the two most important things that you care about when you get a transceiver is its sensitivity and its selectivity. And it's true for any radio, even your home AM radio. If you've got crappy sensitivity and selectivity, you got a crappy radio.
Mhm.
Sensitivity is the ability to detect a signal. In other words, what's the minimum power level signal that it will detect? You know, is it down in the microvolt range or is it in the millivolt range? In some cases, it may have a preamplifier that you can, or two that you can switch in to amplify the signal more. Or you can get an external preamplifier. Sometimes, particularly, I think I've seen them in the VHF, UHF, where you mount it at the antenna.
Satellite people do that.
Mhm.
Because you're usually dealing with very low level signals. And you need to boost it up because you're going to lose a lot of the signal in the coax going to the antenna
Mhm.
when you're up in the UHF and above. So you got to boost it back up because you're going to lose it.
Always buy hardline at a few dollars per foot.
Yeah, but you're still going to lose. Selectivity is the ability to discriminate between two different signals. So if you have a signal very close to the one that you're trying to receive,
Mhm.
if you have poor selectivity, which means it has very wide band width, you're going to get both of those signals and they're going to interoperate, get intermodulation and things like that. And you'll kind of hear both of them.
Mhm.
If you had very high selectivity, it means you can single out that single frequency better. Now, depending on how close it is, you know, there's a limit to how much, even with digital signal processing, how good a filtration you can use to select an adjacent frequency. What term describes the ability of a receiver to detect the presence of a signal?
Charlie,
You sure?
I hope so.
I was pretty sure. Geez.
Sensitivity is presence of signal. So that'd be Bravo.
Oh, goodness sake.
What term describes the ability of a receiver to discriminate between multiple signals?
Okay, that would be, Charlie,
Okay. You were thinking ahead.
I guess. Thank you.
Where is an RF preamplifier installed?
Preamplifier, okay.
Always, where?
Between the transmitter and tuner at the
Well, it
output.
doesn't show up on mine, but there's different color
It
fonts there.
does, yeah.
at
Uh,
the-
Remember to fix that.
You were just pointing out the incorrect answer.
Yeah. Yeah, don't go by the black. Between the antenna and the receiver, either at the antenna or at the front of the receiver, or in some cases, it's built into the receiver.
Is that one of my colorblind spots? Which font is slightly different on color?
B is in black and
Mhm.
the other ones are
Oh.
Blue.
Mhm.
Yeah. Yeah. I can see it now that I'm looking at it, but
okay. One of the early designs for radios was what we called a tuned RF, where you had multiple amplifier stages that were all tuned. So that kind of gave you the bandwidth filtering and amplification. But you had to, like in the case they show 3 stages, they all had to be ganged together. So when you tuned them, you tuned all 3 of those at the same time. So you wound up with those multi gang capacitors that you used to tune it back in the old days when didn't have varactors and encoders. But they worked pretty well. They didn't have very good selectivity. But pretty good sensitivity.
Mhm.
And in fact, I think there was a regenerative version of that with some feedback, and you really get good sensitivity. But it didn't help selectivity. Then they came out with the heterodyne or super heterodyne. And heterodyne means that you're basically mixing 2 signals together to convert to a different frequency. The super heterodyne kind of referred to doing multiple stages of that. Whereas in this one, they're just showing, in this really, I wouldn't call a super heterodyne because it's only got 1 intermittent frequency. So they're taking your input signal, mixing it with the local oscillator, which means they're multiplying those 2 frequencies together. And one of the products that you get out is an intermediate frequency. And they try to filter out the other ones that you don't want. And then you amplify the intermediate frequency because in most cases, it's going to be a lower frequency and it's easier to filter and deal with and then demodulate it. In the true super heterodyne, you probably have a second mixer stage and convert it to even lower frequency, intermediate frequency. Modern radios now have some form of what we call software-defined radio or direct conversion. They may be a hybrid where they'll have an analog front end, RF amplifier, maybe bandpass filter, and then go into an analog to digital converter and do the digital signal processing. In some cases, it could be total, and we would call it an SDT, a software-defined transceiver. And you're bringing the input signal directly into an analog to digital converter and digitizing it, and then doing all the operations on it, the filtering and mixing and all the equivalent things, doing it in software. One of the reasons, well, I guess there's several. One is cost. You can actually do a lot of the stuff cheaper in software than you can in hardware. You don't have to have all these toroids and other things. It allows you to effectively change the hardware by reloading the software. Whereas you wanted to make the same kind of change to put a different kind of bandpass filter in your analog receiver, you got to physically change that hardware out. You can change the filter on the software defined just by reprogramming. And the thing on the bottom is kind of showing the processing that's going on where you're coming in. They may have a hardware front end where they still have an RF amplifier, but then they're going into the analog to digital converter to digitize it. So everything from that point is all digital or software operations, digital filtering. And then at the end, converting it back from digital to analog. So you could have an analog audio amplifier or headset amplifier. So probably every major manufacturer's newest radios are software defined, at least partially. And it allows you to have waterfall displays, neat things like that. In order to do the super heterodyne type stuff, you need what's called a mixer, which takes two signals, multiplies them, and gives you an output. In a simple mixer, you get the input signal, you get the local oscillator signal, in other words, both inputs, and the sum and difference of those. So you actually get four. So, but we don't care about the input or the local oscillator. We only care about the sum and difference. So in most cases, you want to pick the difference, and that gives you the lower intermediate frequency. And the sum and difference frequencies are usually far enough apart, it's easy to filter all those other ones out. This is showing kind of mixer operation where in the first one called down conversion, you can see we have an RF signal coming into the mixer. We have a local oscillator coming in, and we're getting an intermediate frequency out. Okay. So if you look at the chart above, there's the local oscillator, which is a higher frequency than the signal that you're trying to detect. And that difference IF frequency is way over here. So this is the one I operate on. So I don't have to, these are far enough away, I don't have to worry about it. In the case of what they call up conversion, I've got my intermediate frequency coming into the mixer, a local oscillator, and RF coming out. Okay, so I'm converting that intermediate frequency back up to an RF frequency. And you can see I get the two sidebands, which are the sum and difference. So that's how you would actually transmit like an AM signal or FM, or excuse me, single sideband, where I get this output and then I have to filter out that carrier in one of the sidebands. If I use what they call a double balanced mixer, then I don't get the carrier signal out. I get the sum and difference. And it's slightly a different mechanism, but
Have you ever operated double suppressed sideband?
it'd be hard. So which of the following is used to convert a signal from one frequency to another?
Betty Crocker probably does it a lot.
We can talk about this. Which of the following is used to convert a signal from one frequency to another?
Yeah, this one again has got the blue and the black. I don't know why. I must have duplicated somewhere along the line, and
Well, at least you're highlighting the correct answer.
this time,
Mm-hmm.
but on my screen, I can't tell the difference. They all look the same.
It's all damn soft anyway.
Mixer.
So we'll go with the mixer. It's used to convert a signal from one frequency to another.
Good old Betty Crocker.
Essentially, it's a frequency multiplier, and you multiply those two together, and you get the two original and the sum and the difference.
Mixer.
Okay, so in addition to a mixer, you need a local oscillator. Sometimes it's called a VFO, variable frequency oscillator, to generate one of the signals that you use in the mixer in order to generate that third frequency, your intermediate frequency, or your RF frequency if you're going in the other direction. And this is a typical oscillator, simple single transistor oscillator circuit. I believe this is a Hartley configuration. You don't need to know that until the general exam, and then you have to know the difference between Hartley and Colpitts and Pierce. If there were two capacitors here and the feedback was in the middle of those instead of the coil, it would be a Colpitts.
I can
Just,
tell the difference between the ABBA and Black Sabbath.
I don't know, but I know the difference between Colpitts and Hartley. What is the name of a circuit that generates a signal at a specific frequency?
Delta.
Delta.
Hi.
Okay. Next comes the modulator. To convert our speech signal. And actually perform modulation on the carrier. And what we're showing there in the nice little moving graph is the baseband or the voice signal and how it would modulate an AM carrier where you see the amplitude changing proportional to that input signal. And in the case of FM, you're seeing the frequency change in proportion to it, and the amplitude stays constant. So in one case, the frequency is constant, you change the amplitude. In the other one, the amplitude's constant, you change the frequency. It doesn't show phase shift modulation, which is kind of hard to show, but that would be constant amplitude and you're changing the phase of the signal, and it's hard to display it. But there isn't, in practice, there's not a lot of difference. This is showing for AM modulation, we're taking our voice signal into the modulator along with the carrier signal, and we get the modulated AM waveform out. It's actually, if you notice the 0, which they don't show here, right through the middle, and what you're actually seeing is both of those sidebands, the upper sideband and the lower sideband waveform. So when you detect it, normally you just look at one half of that envelope. Which of the following describes combining speech with an RF carrier signal?
Could be.
That would be Bravo.
No, not because it's in black. I
Could
guess
be.
every one of these is that way, isn't it?
These seem to be.
You didn't mark the answer key correct. Could be.
That's what I thought, B, Bravo.
Could be.
Now we're going to combine speech with the carrier to generate a modulated signal. So what is that process called?
Cal.
Can't figure that one out.
Can't figure
Well,
that.
I see Bravo. I don't know if it's right or not.
It's called modulation.
Hey, modulation.
Right. You want to modulate the carrier with your voice. Okay, so we talked about transceivers, which just combine receiver transmitter, transverters, which allow you to convert to another band, usually a higher band. Power amplifiers just increase your transmitted power output. It may have and should have some form of mode switch, could be automatic or manual. In receivers, you care about sensitivity and selectivity. I don't know which one is more important, depends on what you're doing. If you have weak signals, but few of them, selectivity doesn't do much for you. You care about sensitivity. If you've got a lot of, like a pileup, you got a lot of signals close together, sensitivity isn't your problem. You need selectivity. But obviously you need a radio that does both well, because it depends on conditions as to what you need.
And most of the time, you're turning down your sensitivity instead of turning it up.
Yeah.
Mhm.
Yeah, sometimes on mine, it switches the attenuator in automatically, depending on
Yeah.
the signal level. RF preamplifier could be in the radio, could be external, could be at the antenna, but it's somewhere between the input of the radio and your antenna. We use mixers to convert from one frequency to another, either up or down. Oscillator to generate a specific frequency. And modulation is the process of combining speech or a digital sound, in case of digital modes, to modulate a carrier signal.
Mhm.
That was really confusing.